So here's the new problems in the test review. Number 3, the general formula A equals A sub 0 e to the RT. A is the amount present after time. A sub 0 is the initial amount. R is the rate. And this can be used to represent continuous growth or decay. And we've got a bacteria colony that is initially 10 spores and has a growth rate of 0.55. Oops, I kind of crossed that out. Write an equation after T days. So here's my formula. A equals the initial amount, E to the rate times time. I want that decimal to be bigger. Okay, how many bacteria are there after 7 days? So that's when T is 7. Show your calculation and round to the nearest thousands. That's 3 places after the decimal. We need our calculator. I'm going to type 10 e to the 0.55 times 7. If you have the older type of print on your calculator with me where the x, like I do, like where the exponent is not tiny, you have to have these parentheses around the 0.55 times 7. And to the thousandths place is 469.931 spores. All right, for number 4, in 1985, the population of Gaithersburg was 250,000 people. Over a 20-year period, that says rate at which the number of residents grew exponentially. In 2005, the population was approximately 338,000 people. Now they give us an equation. Clearly explain the meaning of each number. So the 250, that is the initial amount of people in thousands that, well, let's go initial amount, of people in thousands in Gaithersburg. And then 1.35, that is the growth rate. When T is a 20-year time period. What is the percent growth every 20 years? If I think back to my exponential equation, it's the initial amount and then 1 plus, 1 plus R to the T. So 1 plus R equals 1.35. So solving for R, which is the percent, R is 0.35, which is 35%. Write a system of equations that can be used to find the year in which the number of people reaches 750,000. So this is similar to the graphing questions where we are given, it's like the first 2 questions in the review. So I'm going to make y1 750, and I'm going to make y2 the equation that we're given, because I want to find out when what time will these two equations be equal. That'll help me find the year. So now using that system, let's solve it. I'm going to go to y equals, and I'm going to put 750 in y1, 250 times 1.35 to the, and now I have to use x because there's no t. I need a y value that's more than 750. So I'm going to hit window, hit this button window, and I see that the y max is 10. That is not high enough. I need a y max to be over 750 so that I can see this horizontal line. So I'm going to round up to 800 and then press graph. So the blue line here is the 750. Here's my exponential growth of the population. We go second, trace, intersect is choice 5. Move your cursor to that spot. Hit enter 3 times. And it tells us that value. Okay, so I've copied the screen over so that of the calculator so I can type my answer here. Find the number of 20-year time periods. Since t is a 20-year time periods, this independent variable t, or here x, is 20-year time periods. So it will take 3.7 20-year time periods for the population to reach 750,000 people. Okay, now use the other video for all the other problems.